Oh, that's better. Hello and welcome to Tweed's Garage, where in this video we're going to be torquing up the flywheel and fitting the clutch assembly to the Riley. So welcome back. We're here in the workshop at the moment, just going to explain a few things, little jobs I've done before doing the clutch and torquing up the flywheel nut. Because it's warmer in here, got the heater, and then we'll be going into the garage, which is a bit of a tight squeeze, as you know. So yeah, it'll be crowded in there. So first things first, first thing I had to do was torque up the flywheel. So cleaned up the taper, put the flywheel on, done it up as tight as I could by holding it by hand. Now, when I took it off, the way I stopped the crank from spinning, and it is a sort of a known thing to do, because the crank's flat, you can sort of pack the crankcase out with blocks of wood so that it can't move. I wasn't 100% happy with that idea, because old cast iron, quite a large surface area, possible flex, possible cracking. Yeah, so I'd done it to get it undone because I didn't know any better. But when I was doing it up, I thought that, you know, there must be a better way. There must be some way of holding the flywheel and tightening it up. So what I'd done was I made a tool. Here it is. Looks like a sort of medieval torture, but this I can assure you done the trick, as you probably saw from the little lead-in video. So what it is just a piece of angle iron, which I just had lying around. You could use a bit of flat bar if you had it. 2 holes drilled to match the holes on the crankcase, and then 3 pieces of angle iron welded on, and then each one mating with a tooth on the flywheel. So how did we go about it? Well, first found bits of scrap to do it with, and then the next thing to do was to position where it was going to go on the crankcase and figure out where the holes were. So I sort of put it in place, and then drilled with a pencil, just marked through roughly where the holes were, so I knew the rough position, and then needed to drill the holes. Now, I've always struggled, and some of you probably know, and you're going, yeah, it's easy, I know this, but some people might not know. I learnt this really easy. Trying to find the centre position for 2 holes. What you do is you get your calipers, and then you measure, because I've always tried to do this. I've always tried to sort of roughly by eye work out, you know, where the centre of the 2 holes were, and go like that. And it's okay, you get away with it sort of 9 times out of 10, but sometimes it's just not good enough. So what you do is you measure the inside of the hole, like so, and then you measure the outside of the holes, like so. So it's a bit difficult doing this not on the bench, like that, to the outer edges. You take your 2 measurements and add them together, divide by 2, and that gives you the centre of your holes. It's easy, isn't it? Good, this math. Maths we call it over here. America, you call it math. Don't know why, just do. You could also do it with studs. If you wanted to, say, you know, make a plate to go over 2 studs, you just measure the outside edge of the studs, inside edge of the studs, add the 2 together, divide by 2, sorted. Yep, and it worked really well. So centre punched the first hole where its rough position was, and then measured and marked where the second hole was going to be. Centre popped and drilled them, and yeah, they lined up lovely on the crankcase. I needed some bolts to clamp the flywheel clamping tool to the block. So as before, I had some spare engine bolts, like I've said before. So I just put a die on and wound the thread further down so that they went through the block. But there was enough thread on there for the nuts to do up behind the block. So I've got my bit of plate with a hole in. and then mounted it back in position on the block, and I cut 3 pieces of angle iron that I had laying around. You could use a flat bar. It's just that when you're torquing the nut up on the engine and the flywheel's pushing against these, if it was just a bit of flat bar, there'd be a lot of force on it, and they would just possibility of them folding over. So with a bit of angle iron, it's got a, you know, it's got a prop edge behind it, you know, helping support this front edge. So bolt it on, and then mark the relative positions of these with a pencil where they were, you know, sort of trying to get them to sit as flat as they could against the gear teeth, and then back in the workshop and tacked them into position, then back out into the garage, bolted it up, just check that it's you know, that they met with the gear teeth on the starter ring nicely, and then back in the workshop and weld them up. Good, you know, good enough to do the job. It's, you know, it's just a tool to do a job, so probably hopefully only use it the once, but yeah, handy nevertheless. So as you'll see, that worked really well. So bolt it on, position it against the flywheel nice and tight, and that allowed me to gently torque the nut down, gently, yeah, allowed me to tighten it down to its specified torque settings. And so that's done. As you can see, flywheel's on. Next job is the bolting the clutch on. And I showed you, if you saw it, the little video of all the bits and bobs that Keith down the road gave me. And I did show you, I had in the bottom of the box was a snap-on clutch alignment tool. Can't remember the part number. I'm sure somebody will want to know. Oops. A37A. So what you have your, I've sort of figured it out. You've got your nose. This is the nose that slides down into your clutch plate to line your clutch plate up, and then this end, you put these different, I'll show you there. Put these different size collets on to correspond with the hole that you have in the end of the flywheel. And then what you do is they go on here. Let me show you, whilst we've got plenty of space. So you take the end out, put your corresponding collet on, and that's got a taper at the end to tighten it up. Try and find one that will go on nicely. No, let's try another one. There we go. Yeah, so that goes in there. Like that. And then put that end in like that, tighten it up. And then this draws this taper down through this and spreads that out to tighten up into the end of your flywheel. And then you put your clutch on and then tighten this down so it beds down, this taper beds down into your clutch plate and lines it up. So we're going to use that, so we see that in action, but unfortunately on the Riley it wouldn't fit because the end of the crankshaft, the end of the flywheel has this bearing in, and as you can see my the biggest one's about that. There is another one which is too big. That won't fit in there. So had to turn to the trusty Colchester and turn one up. So popped in a bit of aluminium, turned it down to diameter to be a sliding fit for the bearing. And then drilled a hole in the centre for the shaft to go through, and then carefully bored using the taper on here, measured the taper on here to set the tool up. Then used a small boring bar to turn the taper in the end of the collet. So, and then take it out and cut it 4 times, one all the way down the middle. This is it's not very neat and tidy, but like I said, you know, it's only going to be used for one job. Yeah, so then that will go on here, in there like that. Then you can tighten that down on there, and then all we need to do first is just put our clutch plate on, and it's ready to go on. So let's go to the garage. It's a tight squeeze in there, so no messing around at the back. Let's get on. Right, are you all in? Okay, can you see from the back? Right, sorry it's a bit snug in here, but we haven't got a lot of room. So yeah, let's take this off. We don't need this anymore. So I got on beforehand, as I said I was going to do, and got the angle grinder out, got busy on all the clutch assembly and the flywheel, and all looks good. Springs are good. Release bearing is all good, and yeah, and there's it's unusual. You take the bearing apart, and you think there's only like the sort of the top race, the middle bearing runner with the roller bearings in, and in all the grease and everything, it looked like it just rode on the release basket. But on closer inspection, after cleaning it up, there is actually a hardened steel race pressed into that steel pressing for the release bearing to run on. So that's good news. Yeah, our clutch plate was in good order, so we can pop that back in. So the first thing to do is to put the what would you call it, the input shaft, the gearbox input shaft bearing that sits in the end of the flywheel. I'm just using the tool just to position it. I've packed it with grease, high temperature grease, and yeah, it's probably the wrong grease, somebody will say, but it's better than no grease. And I've turned up this little insert tool to get it to sit nice and flat and flush, and turn just a sort of like a 1mm depth on it, just to sort of push it in just a little bit, to make sure I've got, you know, enough clearance and it's not riding on the splines aren't pushing right up against it and putting a bit of pressure on the bearing. I'm sure it's fine. These old vintage cars, some of the engineering accuracy was surprisingly good considering the tools they had at the time. So this just rests on the outer race so as not to strain the bearing. There we go. Ah, balls. Okay, if you spotted my deliberate mistake there, I didn't check the inside diameter of the clutch splines for the tool, and in our infinite wisdom, Riley have decided that this is bigger than this, so you can't get the tool out if you used it. This is the problem I didn't allow for. The output shaft on the gearbox has the splines, the relief grooves machined below the surface of the outer edge of the shaft that rests in the bearings. So this means that my adapter is machined to this diameter, and the pressure plate on the clutch also has a matching splined hole in it, so it will go over. But my adapter is solid, so it catches on the relief grooves for the spline. So I'm not going to give up. I'm going to use the tool. So we're going to do a bit of machining on it to get it to fit. So back to the workshop. Stop moaning, Jenkins. The exercise will do you good. And the second problem I need a mechanical solution for is compressing the clutch assembly, because these are the bolts used to fix it down, and when you pop the clutch assembly into the flywheel, the gap between there and the flywheel with the springs at full extension is too long to be able to get these to bite. And doing it single-handedly, you can't press this in by yourself. I suspect the factory probably had something that wound onto here like a bit of a puller and hooked under each side of this plate to compress it down. But I'm not going to make one of those, it's far too complicated. So what I'm going to do is go back to the lathe, turn up some long bolts and some nuts so that I can locate them through with the nuts on the top, and just gradually wind the nuts down in an even pressure to sort of pull the plate in. That is the plan, and it will go well. So the first job is to get some what? So the first job is to take a bit of hex bar, chuck it in a lathe, turn up 3 nuts, and then turn up 3 bolts. So here is a little turning montage. So the next job to do is to adapt the adapter, and the output shaft on the gearbox has 6 splines. So I've got a ER32 hex block like this, so I can put the adapter in here and then pop it in the vise on 2 of the flats, machine a slot and then turn it to the next set of flats, machine, and just keep going until I've gone all the way round, and then because it's 6-sided that will give you the 6 slots. So let's go to the mill over there. So unfortunately I didn't have the mic turned on, so I'll just talk you through. So it's just a case of reassembling the clutch. So put the clutch plate in, and then the pressure plate and a backing plate, and holding it all together with all the springs and cups in place, which is quite tricky. Positioned it in place and put the clamping bolts in position and put a bit of tension on it, and then that allowed me just with a screwdriver to line up all the springs that had sort of dropped out of position, because you're fighting gravity and everything's trying to fall out. So with the springs in alignment, then it was apply a little bit more pressure by doing the nuts up, and then install the clutch alignment tool and proceed to tighten it all up. The bolts, the assembly bolts with the nuts, yeah, they work, as you can see, work really well. And yeah, as you'll see, I put the clutch alignment tool in, but just the sort of side forces of the plate when you bolted it up kept moving it, and yeah, every time I took it out, it wasn't quite in line. So what I'd done was just release the pressure slightly and go the good old-fashioned route of putting a brass bar down there and moving it around by eye and then gently tightening it back up again. Yeah. So in the end, I don't think I had my mic turned on, but also the clutch just kept moving even with the alignment tool in. So I've done it the old-fashioned way and done it by eye. That's the way I've ended up doing, I think, pretty much all the clutches I've ever changed. So yeah, we hope there's enough movement in it and the clearance on the shaft when we bolt it back to the engine. We shall see. And but hopefully it'll be all right. There we go. So we just button this up. But these work well. So this is one little victory out of the two engineering problems. And what would I rather be doing? Playing on the milling machine and the lathe, or watching Strictly Come Dancing in the warm with a cup of tea or a beer? Nope, definitely out in the workshop. And then just the thrust bearing to go on. That'll give it a bit of a grease in. And then generally what you do is take the floorboards up, unbolt the cover on the bell housing, and occasionally dribble some oil in there, but not too much oil, otherwise it goes on the clutch. And yeah, nothing like a bit of simple maintenance. So I can see why these go dry. People don't want to keep pulling the floorboards up. And this collar screws on, and then it's got a locating screw to put it in place. And I've put a little yellow paint mark on it so I know where the screw is. And then somewhere around here, oh, where's that gone? Here it is, a spanner that I old spanner that I mullered to make another tool up. Don't worry, it was It was well worn, well past its sell by date. Should be about it. About there. When I took it apart, it was roughly, this collar was roughly flush with the end of the clutch pressure plate. So then hopefully the screw hole will line up with the threaded hole. Let's see. At last, something's gone right first time. Yep. Let's give it a little. There we go. One clutch reassembled, ready to go back in the car. So there you go, clutch assembled. Easy as pie. Simple, told you it was going to be, even though we had to do quite a lot of engineering. But we all like a bit of engineering, don't we? Do you like a bit of engineering? Yeah, I like. So, yeah. So the next video, we're going to put the engine back in the car. And it's going to go as smooth as anything. And I don't need to make any more tools. No, hang on a minute. I did have to make one. And there'll be a video for that. So, see you again. If you enjoyed the video, give us a little like and even subscribe to see more nonsense coming along. And I'll see you next time. Cheerio. Anyway, better go and find those spring washers.